All right, good morning. Happy Friday. I am enjoying myself in Oregon, but I am still with you, and I want to make sure that you get your notes for 1.3b day 1, solving and graphing inequalities. So yesterday we went over interval notation and we went over graphing. Okay. But yesterday we just started with an answer. Today we are going to actually solve the inequality, get our answer, and then graph it. Okay? So, but before you can solve an inequality, you have to be introduced to what's called the golden rule of inequalities. And that says when you multiply or divide both sides of an inequality by a negative number, you must flip the inequality symbol. So let's look at an example. So if I have negative 3x is greater than or equal to 15, okay? In order for me to solve it, I have to move this negative 3, okay? I do that by using inverse operations. I don't want it with the x, I want it on the right side. So I'm going to divide both sides by negative 3. Okay? When I do that, that cancels to a 1, and I get x but given that I'm dividing by negative 3, I have to remember that x it's going from greater than and equal to, less than or equal to. I have flipped it. The alligator was eating the x, now it's eating the answer. Okay, I have to flip it because I'm dividing by a negative. So I get, the answer is negative 5. Okay, x is less than negative 5. So I have solved for my variable. We will be solving for the variable just like we did equations. We need to start with our distributive, combine like terms. Do we have a variable on both sides? Then we're going to have the number, and then we're going to solve. Same steps, okay? Depending on your inequality, will determine how many steps that you have. Once you get your answer, so we got x is less than or equal to negative 5. You want to make sure that it's in the right order. Variable, our inequality symbol, and then our constant, okay? Then you're going to determine, do I need an open or a closed circle? Well, you look at your inequality symbol. We're going to need a closed circle because we have that equal sign underneath. Then you draw your circle on the number line, and you determine which direction your arrow goes. Which direction your arrow goes, whether it goes towards the negative infinity to the left or the positive infinity to the right. All right, so let's graph our example. Let's graph a couple examples, actually. Let's graph x is greater than 1, and let's graph x is less than 1. Okay. So, in order for me to graph, if I were to get the answer from solving my inequality that x is greater than 1, I would find 1 on the number line. Okay. Then I'm going to use an open circle because I have, it matches my greater than, right? I don't have the equal underneath. And because x is greater than 1, I'm going to draw my arrow in the direction of positive infinity. This is a good review from yesterday. If I have a closed interval, meaning I have that equal sign underneath my less than sign and x is less than 1, then I'm going to go to 1. Okay? I'm going to use a closed circle, and I'm going to draw it in the direction of negative infinity because the value of x is less than 1. Now, if I were to write this in interval notation, if x is greater than 1, okay, the smaller value would be 1. That would be my smallest value. I have an open circle, meaning it's an open interval, meaning I would need to use parentheses. I would do a comma. I would do my infinity. And when you use infinity signs, you always use parentheses. So let's do the interval notation for the second example. Well, the smallest value would be to the left. The greatest value on this one would be 1. And I'm using a less than or equal to, which means I must use closed interval notation or my bracket. Excuse me. And then on the left, I'm going to have a negative infinity and a parentheses. All right. So let's do some examples. We're going to solve the inequality, and then we're going to graph the solution to the inequality and write it on the number line. All right. And we're also going to write the solution using interval notation. So all three notations that we learned yesterday, but we're adding the added value of being able to solve the inequality. And we're going to follow the same steps that we did when we solved an equation. Distributive, combine like terms, variables, numbers, solve. Okay, so here is my equation. 6 times x minus 1 is greater than 12. So do I have distributive? Yes, I have parentheses. Okay. So I'm going to start with my distributive. I'm going to multiply 6 times x and 6 times negative 1. 6 times x is 6x. 6 times negative 1 minus 6 is greater than 12. All right. I don't have any like terms. I don't have a variable on both sides, but I do have a constant that I need to move to the other side using inverse operations. So right now it's minus 6. I need to add 6 to both sides. Okay. So this cancels. I'm left with 6x is greater than 18. Then I move on to my solve. So this 6 needs to go away. Needs to be moved to the left, from the left to the right. I'm going to do that using inverse operations. Right now it's multiplication. So now I'm going to divide both sides by 6. Dividing by a positive number, so I don't need to flip my inequality sign. Those cancel, and I'm left with x. Actually, I'm going to write it right here for you. X is greater than 3. 18 divided by 6 is going to give me 3. So my answer is x is greater than 3. That's my inequality. Now I want to write it in interval notation. So what's my smaller value? Well, x is greater than 3. So smallest value is going to be 3. I'm using parentheses. I'm going to do my comma, and I'm going to do my positive infinity, close my parentheses. So when I graph, I'm going to go to the number 3 on the number line. I'm using an open circle, and I'm drawing it in the direction of positive infinity. All right, let's do another example. I have x minus 3x minus 6 is greater than 4. So go through your steps. Distributive, combine like terms, variable, numbers, solve. Well, I know I don't have distributive. There's no parentheses. But I definitely have combined like terms. I have an x and a negative 3x. When you're doing combined like terms, remember, you're only doing the left side of the inequality sign or the right side. You're not crossing over the inequality sign. So x minus 3x is going to give me negative 2x. Minus 6 is greater than 4. I don't have a variable on both sides, but I do have the number. So I want to move this negative 6 to the right side using inverse operations. Right now it's minus 6. I'm going to add 6. And I get negative 2x is greater than 10. Now, I need to solve. So, this -2, I'm going to divide both sides by -2. And now I am dividing by a negative. So, when I write x equals, right now the alligator's eating the x, right? It's eating the side of the x. I need to flip it. And I come up with x is less than -5. So this sign flipped. The inequality sign flipped. All right. Now I need to do my interval notation. So x is less than -5, meaning that my -5 is the greater value. I need parentheses, my comma, and I use -infinity on this side. Okay. Now I can write it on my number line. I find the -5. Okay. I need an open circle, and I'm going to draw it in the direction of -infinity. Remember, this right here, flipping the sign, is the golden rule of inequalities. All right. Now, let's do number 3. I have 5 minus 3x is less than or equal to 13 plus x. Great. So, do I have distributive? No. Do I have combined like terms? I don't. How about variable? I do. I have a variable on both sides. I have a -3x here, and I have an x here. So I'm going to move the x. I'm going to move the variable with the smaller coefficient, which would be x. So I'm going to subtract x from this side, subtract x from this side. 5 minus 2x is less than or equal to 13. Great. Now, numbers, yes. I do have the number step. I need to get rid of this constant. I'm going to move the one on the side of my variable by using inverse operation. So -5, -5. These cancel. I have -2x. It's less than or equal to 8. Remember, when I am what did I do? Oh, I'm sorry. I'm sorry. Even in my video, I'm sorry. So I'm going to subtract x. I have -3x minus x is 4x. Sorry. All right. I'm on the right track now. 4x. Apologize. Put that right in your notes. All right. So -4x is less than or equal to 8. Okay. Now, I'm going to divide. I'm going to do my last step of solve. So I'm going to divide by -4. I'm going to divide by -4, both sides. Now, golden rule of inequalities say I must flip that sign. So x is greater than or equal to -2. Okay? X is greater than or equal to -2. Then let me do my interval notation. So I have x is greater than, so -2 is going to be my smaller value. I need to use a bracket this time because I have the greater than or equal to symbol, my comma, and then infinity. Then I'm going to close with parentheses. So When I find negative 2 on the number line, I need to use a closed circle, and I'm going to draw my arrow in the direction of infinity. Whew. All right. Sorry about that. We made it through, though. We made it through. Now, 3 minus, parentheses, 2x minus 7 greater than or equal to 34 minus 6x. All right. So let's go through our steps. Distributive. Combine like terms. Let me move this up. Combine like terms. Variable, numbers, solve. Wonderful. Now, do I have distributive? Yes, I do. I definitely have distributive because I have parentheses. So let's take care of that first. Remember, if we don't see it, there's a 1 there. If you have that negative sign, there's a 1 there. It's going to flip the signs of everything in your parentheses. So I have 3 minus 2x plus 7 is greater than or equal to 34 minus 6x. All right. Now, ask yourself, do I have combined like terms? Yes, I do. I have a 3. I have a 7. Remember, combined like terms is either on the left side of the inequality sign or the right side. So 3 plus 7 is 10. Minus 2x greater than or equal to 34 minus 6x. Wonderful. Now, do I have a variable on both sides? Yes, I do. Yes, I do. So, the rules tell us to move the one with the smaller, which would be fine. And it will give you the right answer. But you can also, in inequalities, move the one that's going to give you a positive answer. Why would you want a positive answer? Well, if you want a positive answer so that you don't have to worry about the golden rule of inequalities and flipping your inequality sign. But regardless of whether or not you move the small one and end up with a negative coefficient, or move the larger one or move the one that gives you a positive coefficient, you'll still end up with the same answer if you do it correctly. But for this example, I'm going to move this negative 6x by adding 6x to both sides, because by doing that, I'm going to get a positive x. I'm going to get a positive 4x. Instead of, if I had moved the 2, I would have ended up with a negative 4x. So I'm going to have my 10 plus 4 greater than or equal to 34. Okay, great. Now, do I have the number? Yes, I do. I've got constant right there. I want to move it by doing the opposite, plus 10. I'm going to minus 10 from both sides. And I end up with 4x equals 24. Whoops, don't say equals. 4x is greater than or equal to 24. Yeah, don't slip into writing equal signs. We're solving inequalities. So my last step, I'm going to use the number. I'm going to get rid of this number. I'm going to divide both sides by 4. X is greater than or equal to 6. Okay? X is greater than or equal to 6. All right, wonderful. Let's make this look a little more like an inequality sign. Now, let's do our interval notation. X is greater than or equal to 6. So 6 is going to be my smaller value on the left. I'm going to have to use a bracket. I'll do a comma. I'll do the in positive infinity, close it. Then I can find 6 on the number line. I'm going to use a closed circle, and I'm going to draw it in the direction of infinity. All right, get busy. Today you have a worksheet, okay? Get busy. You can work together, but you need to be able to do the steps on your own. All right, have a great day.